let's go on a tangent, where the tangent is actually just solving this problem. So this is an excellence problem. We are given a negative cubic, and we are told at a certain point, P, a tangent has a gradient of -7. And it also intersects the graph again, so at a different point. So for example, it has a gradient of -7, so this could be point P, and as we draw the tangent line, it intersects the graph at another point. And our task is to find the coordinates of the point P. Alright, first of all, they've been a bit rude and they haven't given us the full equation. They've left out this constant k. So let's tackle that first. So they have given us that this point lies on the graph as well as the tangent line. So this x and this y point lies on the graph, which means we can substitute the x value in for x, the y value in for y, and solve for k. So step 1, solve k, or find k. So again, we know a point on the graph, so we can substitute in the values and solve for k. So in for y goes 64, equals -1/3, in for x goes -6 cubed plus k times x, which is -6, plus 4. Actually, at this point, I've done way too much math today, so I'll show you what you can do to skip some of the algebra, which, by the way, is totally fine on a calculus paper, as long as you're showing your calculus steps, right? But this is an algebra step. So if we go menu, equa, and we can do solver, right? This is just a linear equation, so F3 solver works, and we input the equation. So 64 equals is shift dot, right, near the bottom, equals, what is that, -1/3 times -6 to the power of 3 plus or -6x plus 4. Execute, and then you hit solve. Right, lower and upper just means it'll search for a solution from negative like 9 quintillion or whatever that is to positive 9 quintillion. And it gives x equals 2. So in our working, we've shown the equation, right? So we know how to substitute. And then our next line is k equals 2. That is absolutely fine in a calculus paper. Alright, so therefore our equation is -3x cubed plus 2x plus 4. Alright, so we have our original equation. What is next? So we're told that the tangent line has a gradient of -7. So on our cubic graph, there's probably going to be 2 points, right, where it has a negative gradient, or a gradient of -7, so it could be here as well. So we can find the gradient function. So find dy by dx and set it equal to -7 to find the x values. Right, and these x values will correspond to the 2 potential positions or points that the tangent line could intersect. Right? After that, we'll need to check which one works though. But so let's find dy by dx first. So take the power, multiply it out the front, So negative a third times 3 is negative 1, and we reduce the power by 1. The derivative of 2x is 2. The derivative of 4 is 0. Alright, and now we said we need to set that equal to minus 7, because the gradient of the tangent is minus 7. So subtracting 2 from both sides, dividing both sides by negative 1, we get x squared equals 9. So to solve for x, square root both sides. X is plus or minus 3. So again, on our diagram, we know x, or rather the x values of the intersection point could be at negative 3 or positive 3. Alright, and so from here I encourage you to, if you got stuck on this question, take it from here, try find both points, right? You'll need to use the original function, find the equations of the tangents, and check that this point, minus 664, lies on that equation, right? It'll lie on one of them, but it won't lie on the other. Alright, so now let's work towards that together. So step 3, find y values of possible intersection points. A reminder, the tangent could be the upper one or the lower one, because they both have a gradient of 7. However, only one of them will go through the required point. So finding the y values using our original function. So when x is equal to 3, y would be negative a third 3 cubed plus 2 times 3 plus 4, which should be equal to 1. What's that? 6, 10, 27 negative, yep, equal to 1. So that point would be 3, 1. Now when x is equal to negative 3, we would substitute a negative 3 in for x, which will be 9 minus 6, 3 plus 4, 7. So at negative 3, 7. Cool. Alright. So we have two possible intersection points. How do we know which one to choose? So they're both contenders at the moment. We know that the tangent line intersects or crosses the point negative 6, 64. So what we can do is find the equation of the tangent lines, because we have a point and we know the gradient's minus 7. So gradient and a point, we can find the equation and then check that it goes through this other point. So let's do that now. So finding equations of tangent lines. So for one point, so we have 3, 1, and the gradient is negative 7. So using point slope form, y minus y1 equals m bracket x minus x1. So that gives y minus 1 equals minus 7 times x minus 3 which gives y equals minus 7x, what's that, plus 21 plus 22. Cool, so that's one tangent line. Now we can check if it goes through the required point. So when x is minus 6, y should equal 64. So let's check. So check if goes through, minus 6, 64. So in for x goes minus 6. So that gives 42 plus 22, which equals 64. So therefore, point P is at 3, 1. Because when we found the equation of the tangent at that point with gradient -7, it did also go through the required point, -6, 64. Now for completeness, we should of course check the other point, just in case it could be either. So -3 and 7. So this is just an extra check. Again, the same gradient. So y minus 7 equals -7, x minus -3, so y equals minus 7x, what's that, minus 21 plus 7, so minus 14, is the equation of the other tangent. And when x equals minus 6, y would equal, what's that, 42 minus 14, 38, 28, which does not go through the required point, right? So we can rule out that point, and we're confident that the only point that P could be is 3, 1. Alright, so a lot in that question, so I'll go over it one more time, just at each point I'll break down achieve, merit, and excellence. So firstly, we realize it's a negative cubic, and they were a bit mean in that they didn't give us K. So that's a bit rude. So what we did is we substituted in a point and solved for K. After that, so that would be sort of the achieved level. After that, we were able to differentiate and set it equal to -7, and we did that because the tangent has a gradient of -7. Cool, and that would be our merit component. Now, we found the values of the turning points, or excuse me, not the turning points. We found the values where the gradient is -7. We then found the corresponding y values using the original function so that we could find the equations of the tangent lines. Right, so we found one equation there, and we also found one down here. Now, with those equations, we had to check that the point -6, 64 was on those lines. So to do so, we substituted in -6 in for x, and in the first equation, y did equal 64, which means that point P must have been 3 and 1. Right, and getting that far by verifying point P would be excellence. If you didn't clearly communicate this, you would sadly only get a merit. Right, so make sure you're clearly communicating that last step.